All right. Ratio variables, the richest variables of all. Statisticians love ratio variables because we can compute meaningful ratios with them and compute percentages and probabilities, and we can really do a whole host of fun statistical analyses if we have ratio variables, because you can turn a ratio variable into an ordinal variable, but you can't turn an ordinal variable into a ratio variable. You can't go get richer data out of weaker data. All right, here we go. Number of cars stopping for gas. So that's numeric. It says the word number in it, right? So we're going to go to a yes. Is there an equal difference between adjacent values? Yes, the difference between 1 and 2 cars is the same as the difference between 2 and 3 cars. Do values have a true 0 point, never negative? Yes. If 0 cars stop for gas, that means there's a complete lack of cars. There's a complete absence of cars, no cars stopped, and you can't have negative cars. So now we have to figure out our values limited to whole numbers or fixed values. We know we're working with the ratio scale of measurement, but now we want to know, is it continuous or discrete? So number of cars is fixed to whole numbers because you can't have a fraction or a decimal of a car. So we've got ratio discrete for the scale of measurement and the type of variable for the number of cars stopping at a gas station. Now let's look at gallons of gas sold. That's a slightly different beast there. So if we think of gallons of gas instead of number of cars, we're still working with a numeric quantified variable. There is an equal distance between adjacent values because we're working with real numbers that function like numbers do. We're not looking at different places in a race or something like that. Do values have a true 0 point that is never negative? Yes, because you're never going to sell negative dollars worth of gas, and 0 means that you didn't sell any gas. Are values limited to whole numbers or fixed values? So if you think about this when it comes to gallons of gas, the answer is no, right? Because you can have cents in between each whole dollar amount. So that would be ratio and continuous instead of discrete like it was for a number of cars. When you look at number of gallons, because you can have fractions and decimals, it's ratio and it's continuous. All right, now let's think of age of your child or age of children, or age for anybody really. It is a numeric variable or quantified, right? How many years have you been alive? There is an equal difference between adjacent values. Someone who's 30 is 1 year younger than someone who's 31. Someone who's 31 is 1 year younger than someone who's 32. Is there a true 0 point? So I like the never negative piece too, because the true 0 point argument can get really strange really quickly if you overthink it, because you could be like, okay, does 0 mean that you don't exist, or does it mean that you're just firstborn? Is it a true 0 point? I don't know. A nice way to kind of fall back if that's hard and it doesn't really make sense about the true 0 thing. Can it be negative? No, you're never a negative age. So we do have a true 0 point because it can never be negative. Are values limited to whole numbers or fixed values? Well, on the surface, it looks like it, especially if you're asking an adult, right? If you ask an adult, they're never going to tell you that hey, I'm 40 and a half, right? No one's trying to round up. But if you ask kids, maybe they'll say like, I'm 6.5, right? Because they can't wait to get older. But even when people respond in an open-ended way to how old are you on a survey, they're not going to put in a fraction or a decimal. But you have to remember that the fraction or the decimal is implied, it exists. So are values limited to whole numbers or fixed values? No, because you can be years, days, months, minutes old. And now, number of credit hours and final grade. All right. I know there's tons of examples here, but I think practice makes perfect. In fact, I know so, especially with statistics. I've been teaching this statistics stuff for a long time, and the more students get an opportunity to practice, the better off they are. It's like learning a new language and some math at the same time. It's pretty tricky. Okay, here we go. Number of credit hours. It is quantified. It's numeric. It says number of. That's always a good sign that it is numeric. Is there an equal difference between adjacent values? Yes. Do values have a true 0 point that is never negative? Yes, because if you have 0 credit hours, you haven't attended college at all. You can't have negative credit hours. Are these values limited to whole numbers or fixed values? Yes, they are. Now, if we measured number of semesters, I would say no there because you can attend college for a fraction of a semester, but number of credit hours, those are always whole numbers. I've never seen a 1.5 credit hour class. If one exists, then we'll call it continuous. Now let's think about final grade. Okay. My eraser doesn't want to erase. The highlighter just wants to stay forever. Okay, final grade. It's numeric, right? It's a percentage. There is an equal distance between adjacent values because we're working with truly numeric data. Is there a true 0 point that's never negative? Yes. Assuming that you're not the type of professor who like docks people extra points so they can have negative grades. I don't think that exists. So no, you can't have negative grades, and 0 means you earned 0 points. A lack of any points earned. Are values limited to whole numbers or fixed values? No, they are not, because you can have fractions and decimals of percents.